The next function that we have is an absolute value function. And so remember that the absolute value function is a V-shape. We see that when x is 1, y is 1. The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of -1 is +1. And the absolute value of -2 is +2. So the absolute value always has that V shape. The absolute value can have transformations, which we talked about earlier this year. Transformations are when you're not a parent function and you're shifting left and right or up and down. And then you have A out front that tells you whether it's facing upwards or downwards. And so the A tells us it's a reflection. Is it facing upwards when it's positive and downwards when it's negative? H can shift left and right, shifting right, shifting to the left, and then the K is moving up or moving down. Y equals the absolute value of x plus 2. So we can already tell that there is a shift on the x-axis. So you probably think that you're shifting over to 2 on the x-axis. Be careful because it's always the opposite of this number. I am actually going to -2, and I could add a 0 here to show that I'm going to -2 for x and 0 for y. You're not shifting it all on the y, but you're shifting over 2. And there's the vertex. So we know that we are here. Here's a rough sketch of where we expect to be. Now we do want to be a little bit more exact than that. And so you would just create your T-chart. We know that we're at -2, so it would be nice to have some numbers at, say, -4, -3. We already know -2 is 0, and then a couple more on the other side. And so when x is -4, we have -4 plus 2, the absolute value of that. The absolute value of -2 equals 2. So when x is -4, y is 2. When x is -4, y is 2. The absolute value of -3 plus 2 equals the absolute value of -1, and the absolute value of -1 equals 1. So when x is -3, y is 1. We already found the vertex to be at -2, 0. When x is 1, we have 1 plus 2. And that's the absolute value of 3, which equals 3. So when x is 1, we have that y is 3. And so what I did was I skipped these numbers in between. So let's look at -1 and 0. When x is -1, we have -1 plus 2. 2 minus 1 is 1, and the absolute value of 1 is 1. So at -1, we have 1. And so we do have symmetry here. What did I do? 1, 3. Is the vertex. So I know that there is symmetry with that vertex. So if I am 1 unit on the left, I'm 1 unit on the right. If I am 2 units on the left, then I know I would be 2 units on the right. If I am 1, 2, 3 units away on the right, then I would be 1, 2, 3 units on the left. So just like parabolas, the absolute value also has symmetry. So once you find the vertex, you need to find a point on the left and a point on the right so you can see where that V shape is. And our condition says that x is less than or equal to -1. Be starting at -1 and everything less than that. I'm going to erase what is greater than -1. And then I'm going to take a look to see what kind of circle should I have at -1. It says less than or equal. So I do need to have a closed circle at -1. The second function is a quadratic, degree 2. We can look at the transformations and the characteristics of this before we get started. It's a degree 2. We know that the tails are going in the same direction. We know that it's negative x squared, and so this would be facing downwards. Here we have no shift on x. If we want to see that, we could just say x minus 0 squared plus 2. This is centered at 0, 2. The vertex is at 0, 2. No shift on x, but it's been shifted up 2 for y. And we know that it's facing downwards. So we have a good idea of where to start in our t-chart. We want to see both sides of it. So we could say -1, 0, 1, and start with that. When x is -1, we have a negative because that's in the function, and then -1 for x squared plus 2, which equals -1 squared is +1 plus 2. The negative out front is being carried along, and our final -2 plus 1 is 1. So when x is -1, y is 1. When x is -1, y is 1. And it's going to be an open circle here. We already have the colored in circle, so we'll be starting there. Let's move on. We already know that 0 is 2. When x is 0, y is 2. That's the center, the vertex. 0, 2, 1. We could just think of the symmetry here. If I have a point here, I know that I'm going to have another point over here. Let's check that symmetry. So we have a negative out front times 1 squared plus 2. 1 squared is 1, and you've got to carry along the negative plus 2, which equals 1. We could do one more point and then just use symmetry. Let's try 2. -2 squared plus 2. 2 squared is 4, carrying along the negative that's being multiplied out front, plus 2. And we get -2. 2, -2. 2, -2. Here is my axis of symmetry going through the vertex. I know there are another one on this side. I can see the U shape. I'm going to take a look at the condition to find out where this exists. It says that the parabola exists when x is greater than -1. It exists when it's greater than -1. Here's -1. It would be an open circle here. It's not at -1. We can see the other function is at -1, but it starts the second that it leaves there and then keeps going out to infinity, out to infinity. Erase any marks that I used. And here I have my piecewise function of a absolute value and a parabola. We have the square root function, f of x equals the square root of x. There is no shift on x. There's nothing being added or subtracted, shifting it up and down. And a is positive out front. I am going to pick some x, y values, and I'm going to make sure that I pick values that work out perfectly in a square root. The square root of 0 equals 0. Our first point would be at 0, 0. The square root of 1 is a perfect square. The square root of 1 is 1. So when x is 1, y is 1. The square root of 2 is not a perfect square. Square root of 3 is not a perfect square. The square root of 4 equals 2. What happens if I was to choose any negative numbers? We like to usually be on both sides. What is the square root of negative 4? Well, the negative under the square root is an imaginary number. 2 times 2 is 4. Negative 2 times negative 2 is positive 4. We will never have two numbers that are the same that multiplied together to be a negative square root. This is 2i, and this cannot be used. Ready to look at the condition here. The square root of x only exists when x is less than 4. X is less than 4. So I do need an open circle here at 4. And then it only goes to 0. That's the only place it exists. So there is your function right there, the square root function, less than 4. The next function that we have is f of x equals 2 to the x. This is a new function that we've been working on. This is the exponential function. Really, the only way to graph this would be to do a chart. Pick some negative numbers. So if we say negative 2, we have y equals 2 to the negative 2. It's very important that you are taking care of negative exponents. How do I take care of a negative exponent? Well, this is in the numerator. So if I put it into the denominator, it changes the sign of the exponent. The negative 2 becomes a positive 2. And now I can evaluate it. 1/4. 2 squared is 4. So 1/4. When x is negative 2, we have that y is 1/4. Negative 2 and 1/4. When x is negative 1, y equals 2 to the negative 1. Put it in the denominator and you get 2 to the positive 1, which equals 1/2. When x is negative 1, y is 1/2. Next, we will do 0, 2 to the 0. Anything to the 0 power equals 1. This is the center for an exponential function, 0, 1. Let's do when x is 1, 2 to the 1 equals 2. When x is 1, y is 2. Do 2 when x is 2, we get 2 squared is 4. And then we're going to check our condition. When x is 2, we get 4. We can see that the exponential function here is going up quickly, exponentials. So what is the condition? It says that when x is greater than or equal to 4. So I would need to know what's going on at 4 then when x is 4. So let's put in 4, 2 to the 4th, 2 to the 4th is 2 times 2 times 2 times 2. 2 times 2 is 4, and 2 times 2 is 4, and so we get 16. When x is 4, y is 16. Well, I don't have a 16 on my graph. So I could just say that this was 16. And then when x is 4, we have 16. It says x is greater than or equal to 4. That would mean a closed circle. And then we would continue that. You can see the functions going up, 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 and it's just shooting up with just a little bit of a curve there. This is where it would be greater than 4. It's going out, out, and I need to erase anything that is less than that. And there you have the piecewise function for the square root of x and for the exponential function.